Integrity, Houston for comm check.
Amy, Integrity has you loud and clear.
Good afternoon, Christina. I have you loud and clear as well. Just a heads up that we did lose the return link sooner than we expected, but we have regained good forward and return. We're glad to be back in comm with you.
Okay, copy that. We made a couple calls in the blind. We'll check to see if you received them. One was about the docking hatch, and one was about a food bob. Did you get either of those?
Negative. Please repeat them.
Okay, copy. We'll call back when we're available to do that, and thanks for the note. We're looking forward to the upcoming burn.
Okay, we copy all, and we are going to...
And Amy, the food bob call was there's a full bob in bag 11 plus a mostly full bob and a few of the condiments, etc. So it's pretty close to 2 full bobs in bag 11. Just want to make sure that you've accounted for that. Let us know if that's too much in one place.
Thanks for the report, Jeremy, and we're good with that.
Okay, and then do you have those DE locker net stowage locations?
We have an option A and an option B. Option A is to put the D&E locker nets into locker Bravo 3 in the purple CTB, but that depends upon how much trash you have stowed in purple CTB and also accounting for the space you'll need for the Ecoless wall net.
Okay, that makes sense. What about option B?
Option B is same locker, Bravo 3 in the yellow CTB.
Okay, we'll get those nets in Bravo 3. And do you want to know which bag it's specifically in? Is that important for you?
Yes, please.
Okay, we'll aim for purple. I'm sure they'll fit now, and then something else might not fit later, so we'll put them in purple for now.
Copy, aiming for purple.
This is Artemis Mission Control in Houston, Texas. We did get that forward link and return link acquisition of signal, and you did hear them call up to the crew and get the confirmation back down from the crew on board the Orion spacecraft, and that did come following an unexpected return link loss of signal, and the return link refers to the downlink capabilities, so the transmission of communication and telemetry from the spacecraft to the ground, but all of that communication has since been restored. There on your screen on the left-hand side, you can now see a live view of the Orion spacecraft, this coming from one of the solar array wing cameras, and in the bottom right-hand corner, you can see the team here in Mission Control Houston, specifically the Capcom or Capsule Communicator console and the Flight Director console. Right now, the Capcom on console and communicating with the crew is Amy Dill, and the Flight Director for Orbit 2 is Fiona Ankoviak. We do expect the final targeting for the upcoming return trajectory correction burn to take place here shortly.
Houston for RTC 2 status.
Go ahead.
During the long LOS, there were a few items that we were working that are nominal for RTC2. First, X-flange heaters are on and prop avionics are configured.
SM prop helium isolation valves are configured and the starfield maneuvers are complete.
Okay, we saw all that happen on board as well. Sounds great.
Integrity Houston, confirmed TLT and orb guide converged. Houston is assessing the onboard solution.
We can confirm that they both converged.
Houston copies.
This is Artemis Mission Control in Houston, Texas. The final targeting for the upcoming return trajectory correction burn, or RTC2 burn, has been completed, and we do expect that RTC burn to take place in about 29 minutes from now. As of right now, it's expected to be a 5.37 foot per second delta velocity burn and approximately a 9-second burn. This will be using the 8 auxiliary pulse-X thrusters on the Orion spacecraft. Here in Mission Control Houston, the team on console is currently conducting their go, no-go poll for that upcoming return trajectory correction burn. And again, this burn will further fine-tune the trajectory and the path of the Orion spacecraft as it makes its final approach ahead of that re-entry and splashdown targeted for Friday, April 10th.
Integrity Houston, onboard solution has been confirmed, and Houston is go for the burn.
Copy, Houston is go. We're continuing.
This is Artemis Mission Control in Houston, Texas. We just heard confirmation that the team here in Mission Control has pulled go for that upcoming return trajectory correction burn, or that RTC-2 burn. That burn is now expected to take place in about 24 minutes from now, and it will be a short thruster firing using those auxiliary thrusters to further fine-tune the spacecraft's path on its return journey back towards Earth. The mission control position here that's responsible for some of these trajectory corrections is the Flight Dynamics Officer, sometimes referred to as FIDO. They are specifically responsible for the atmospheric and orbital flight path of the spacecraft, as well as the lunar trajectory of the vehicle. Coming up ahead of the burn, in about 2 minutes, we do expect the solar array wing positions to be moved and confirmed that they are in position for this upcoming burn. And then about 11 minutes before the burn takes place, we'll also expect to hear a call that Orion is in burn attitude, and that confirms that the attitude maneuver ahead of the burn has been completed.
Integrity Houston, tank pressures are good for the burn.
Integrity copies.
This is Artemis Mission Control in Houston, Texas. Teams and the crew continuing to prepare for the upcoming return trajectory correction burn. That burn expected to take place in just under 19 minutes from now. We did just hear confirmation that the prop pressurization tanks are good for the burn. That confirmation coming from the prop here in Mission Control, which is the propulsion officer, and they are responsible for monitoring the vehicle propellants in order to complete these burns required for mission objectives and trajectory purposes. Coming up in about a minute, we should also hear confirmation that the solar arrays are in position for the burn. The Orion spacecraft has 4 solar array wings. Each of those wings is made up of 3 panels, and each panel is approximately 6.5 feet by 6.5 feet, and the total length of each wing is 23 feet long. So these solar array wings do have to be put in position ahead of any burn. These solar array wings are managed by the Mechanical and Power Officer here in Mission Control, which is the MPO, and they're responsible for the electrical power generation, as well as the solar arrays and the ray rotation mechanisms and power distribution systems.
Integrity Houston, solar arrays are in position for the burn.
We see the same.
This is Artemis Mission Control in Houston, Texas, and we did just hear that confirmation that the solar array wings on the Orion spacecraft are now in position ahead of the upcoming return trajectory correction burn. Again, that burn is scheduled to take place in about 16 minutes from now. The next call that we will likely hear is in about 5 minutes, when the Capcom or capsule communicator here in Mission Control will call up to the crew to confirm that the maneuver to burn attitude will be beginning, and then they will also call up to confirm that that burn attitude is complete. And ahead of that attitude maneuver, the mission control position responsible for those attitude maneuvers is GNC, which stands for Guidance, Navigation, and Control Officer. They're responsible for managing inertial measuring units, as well as global positioning system receivers, barometric altimeters, and the position, state, and attitude health of the Orion spacecraft.
Integrity Houston, maneuver to burn attitude starting in approximately 3 minutes.
We're expecting the same. Thanks, Amy.
This is Artemis Mission Control in Houston, Texas. We are currently about 10 minutes away from the start of the Return Trajectory Correction 2 burn, or RTC2. This is expected to be about a 9.41 second burn with an expected delta velocity change of 5.37 feet per second, using the 8 pulse-X thrusters on the Orion spacecraft to further fine-tune the trajectory of the Orion spacecraft on its path back towards Earth. Currently on your screen, you can see a view of the Artemis Real-Time Orbit website, or ARO. The Orion spacecraft is currently traveling at a velocity of about 3,400 miles per hour, and it is about 114,000 miles away from Earth. Earlier today, it did pass the halfway point of its return back to Earth. Again, it is expected to splash down off the coast of San Diego, California on Friday, April 10th around 7:07 p.m. Central Time, 8:07 p.m. Eastern Time. In just a few moments, we should hear confirmation called up to the crew that Orion is in burn attitude. the Orion spacecraft is currently maneuvering to that burn attitude.
Integrity Houston, integrity is in burn attitude.
We see the same.
This is Artemis Mission Control in Houston, Texas. We're currently at a mission elapsed time of 8 days, 4 hours, and 14 minutes into the Artemis 2 mission, and we are currently about less than 4 minutes away from the upcoming Return Trajectory Correction burn, or RTC-2 burn. This is the second in a trio of burns for that Return Trajectory Correction. The first RTC burn was completed on flight day 7, and then this burn coming up is the second of those 3 burns, and the final Return Trajectory Correction burn will be completed on flight day 10, about 5 hours prior to entry interface. And there on your screen, you are seeing a live view of the Orion spacecraft, the exterior of that spacecraft, and you can get a good look at a couple of those solar array wings, sometimes referred to as SAW. There are 4 solar array wings on the Orion spacecraft that provide power generation. And ahead of this burn, those solar arrays were configured to support the upcoming burn. About 10 minutes ago, the Orion spacecraft also completed an attitude maneuver to prepare for the upcoming burn. Following the completion of this Return Trajectory Correction burn, the spacecraft will complete another attitude maneuver to return to the bias tail to sun attitude. The Orion spacecraft uses a tail to sun attitude as its primary passive or passive safe flight orientation during transit to maintain thermal balance and maximize power generation. So again, that Return Trajectory Correction burn coming up here in about 2 minutes. This is Artemis Mission Control in Houston, Texas. We are now just under 30 seconds away from the time of ignition of that upcoming Return Trajectory Correction burn, which will be the start of that burn. Again, it is expected to be about a 9.41 second burn using the 8 auxiliary pulse-X thrusters on the Orion spacecraft's service module to generate a 5.37 foot per second change in delta velocity. And we do have confirmation that the Return Trajectory Correction burn has started, that taking place at 9:53 p.m. Central Time, 10:53 p.m. Eastern Time. And we also now have confirmation that the burn has completed, again, that taking place at 9:53 p.m. Central Time, 10:53 p.m. Eastern Time.
Integrity Houston, good burn. We are assessing the details.
We see the same and copy.
This is Artemis Mission Control in Houston, Texas, and we do have that confirmation that the recent return trajectory correction burn was completed, and it was a good burn. Teams on the ground assessing the details, but it was expected to be a 9.41 second burn for a 5.37 foot per second delta velocity. Again, these return trajectory correction burns help to fine-tune the Orion spacecraft's path as it makes its way back to Earth, and this was the second in a series of 3 return trajectory correction burns, with that first return trajectory correction burn taking place on flight day 7, and the final return trajectory correction burn is expected to take place on flight day 10, about 5 hours prior to entry interface.
Integrity Houston, confirm a good burn, and prop post-burn reconfiguration is complete.
We copy all, and we have a gorgeous view of you out window 2.
Awesome, we're waving at you.
We are too.
This is Artemis Mission Control in Houston, Texas. About 4 minutes ago, the second return trajectory correction burn was completed. That burn taking place at 9:53 p.m. Central, 10:53 p.m. Eastern, to further fine-tune the Orion spacecraft's path on its return journey back to Earth. We did get confirmation that it was a good burn. Again, this burn was executed using the 8 auxiliary pulse-X thrusters on the Orion spacecraft's service module. Now that the burn is completed, the Orion spacecraft will conduct another attitude maneuver to return it to the bias tail to sun attitude. Again, the Orion spacecraft uses a tail to sun attitude as its primary passive or passive safe flight orientation during transit to maintain thermal balance and maximize power generation. This is Artemis Mission Control in Houston, Texas. You're currently seeing a view of the Artemis Real-Time Orbit website, or ARO, which is available at nasa.gov/track-Artemis, and it provides updates on the Orion spacecraft velocity as well as its distance from the Earth and from the Moon. Now the Orion spacecraft and its crew, again on their return leg of their journey, expected to splash down off the coast of San Diego, California tomorrow on April 10th. Now that the return trajectory correction burn 2 is complete, the crew will move into some final activities for their day. They will continue to complete some cabin configurations to prepare for tomorrow's re-entry. And then also on the timeline, NASA astronaut Christina Koch and Canadian Space Agency astronaut Jeremy Hansen will complete an off-nominal waste management system developmental flight test objective, during which they will perform a fit check of the system before putting on their Orion Crew Survival System, or OX suits. Following that developmental flight test objective, there will also be some additional stowage tasks. So the 4K encoder on board the Orion spacecraft will be disabled and also stowed to prepare for re-entry. There will also be some final configurations for the hatch entry, as well as some final configurations for the docking hatch opening system, and some final toilet maintenance, as well as some data transfer for the actigraph, which is a device that the crew is wearing. So that data will be transferred to their portable computing devices, or PCDs, and then downlinked to the ground for that data collection. Additionally, there will be some final AGA readings, or anomaly gas analyzer readings, which is a laser-based instrument which detects trace contaminants on board the Orion spacecraft. That AGA device will then be stowed, and then the crew will be moving into their final private medical conference. Again, those private conferences take place at the end of every flight day with the medical teams on the ground, and then the crew will move into a private flight director conference before moving into their pre-sleep period.
Integrity Houston for Delta to ONWMS DFTO procedure.
And Houston, one moment on that. We are not going to stow the RHC per step 23.3 for Reed's upcoming and controller checkout activity. And we are go for your words.
We concur with that RHC plan. So Christina, for you and Jeremy, in step 1.1.2, do not don the adhesive materials or the barrier cream.
We copy all, thanks.
This is Artemis Mission Control in Houston, Texas. That call coming to the crew on board the Orion spacecraft, specifically NASA astronaut Christina Koch, in regards to some upcoming steps related to their off-nominal waste management system developmental flight test objective, during which NASA astronaut Christina Cook and Canadian Space Agency astronaut Jeremy Hansen are going to be performing a fit check of the off-nominal waste management system prior to donning their orange Orion crew survival system suits. There's also a call made regarding an RHC, which stands for rotational hand controller. That made in advance of another activity that NASA astronaut Reed Wiseman will be completing, during which he will be completing some deflection checkouts of the rotational hand controller as well as the translational hand controller to ensure that the crew can track a target, and this is performed as part of the entry systems checkout. Again, the crew is working through some final cabin configuration as well as other steps to prepare for tomorrow's re-entry and splashdown.
test and integrity for hatch entry inspection.
With you.
Okay, Amy, on the docking hatch, the fabric hinges, I see the two fabric hinges. One is by dog 3 and one is by dog 4. And the fabric hinge by dog 3 was not connected to the hatch. It's connected to the ship, but not the hatch. The fabric hinge by dog 4 is connected to both the ship and the hatch. Just confirm that both of these should be connected between the ship and the hatch.
Checking.
This is Artemis Mission Control here in Houston, Texas. Again, the crew is continuing their return journey back home to Earth. That splashdown targeted off the coast of San Diego, California tomorrow at 7:07 p.m. Central Time, 8:07 p.m. Eastern Time. Ahead of that return, I have a special guest joining me here today. I have Jason Norcross, who is the lead for some of the Artemis 2 obstacle course tasks that the crew will be completing once they return back to Earth. Thanks for joining me, Jason.
Oh, you're welcome. You're welcome.
So once the crew lands, can you tell me a little bit about their balance?
Yeah, when the crew lands, they're going to have what we call sensory motor dysfunction or space adaptation syndrome. And what that has to do with the inner ear getting readjusted back to gravity. It's been in weightlessness for 10 days for this crew. And then as soon as they land, they're going to have some real trouble with kind of maintaining their balance, being able to especially move their head independent of their body. You'll often see the crew kind of robotically move a little bit more. And they're also going to be feeling their weight for the very first time.
So tell me a little bit about this obstacle course. So what is the first obstacle course the crew will do, and how soon do they do it after landing, and what exactly are they doing?
Yeah. So the first thing they do, we typically are going to get the crew about 1 to 4 hours after they land, and then they're going to go through what we call a capsule egress mock-up. So we have built a functional task test that's designed to mimic some of the challenges that they would have if they were on if they had to actually egress their very own capsule. So things like confined space, things like up and down head movement, strength challenges, balance challenges, all those things are going to be part of that very first task that they have to do.
Okay, and then after that, there's another obstacle course they do. So what are they going to do for that second obstacle course?
Yeah, so we get them, like I said, about 1 to 4 hours after they land. And then for the second obstacle course, they're going to be coming back on R+1. So the day after they land, they're going to be back here at JSC, and we're going to put them through an EVA simulation. We're going to put them in lunar gravity, and we're going to walk them through several different tasks that are going to challenge them for both the physical and sensory motor approach.
Okay, so do you also conduct similar measurements on astronauts returning, for example, from the International Space Station?
Yes, we do. So we've been doing this study, or a version of the study, with the International Space Station astronauts for the past several years. So we typically get one subject per increment, and in that case, we're looking more of what it would look like for a Mars landing. So in the case for the Artemis 2 crew, we're going to tune everything to lunar gravity because we're trying to look forward to the lunar. But in the case of the ISS astronauts, those that have been in space for 6 months, that's about how long it would take to get to Mars. So we want to test them on R+1, again, the first day after they land, and see if they would be capable of doing any EVA tasks. And so far, the answer has been yes.
Do you expect any differences between what you've seen on the crews from the International Space Station and the crew coming back from the Artemis 2 mission?
I think so. So the reason being is they haven't been in space quite as long. So they're not going to have the same type of muscular challenges that we see with long-duration crew. But the sensory motor challenges may be very similar because those have a lot more to do with the readjustment back to gravity.
Okay, so why do we want to know how quickly that they will adjust to their new gravity?
Right, so the early Artemis missions are, as we've seen, when we land on the moon, they're a busy mission right now. We're looking at 4 EVAs in 5 days, and we're looking at that first EVA right now as being one that we might have to take a little cautiously because of the sensory motor disruption, because of that adjustment from 0G to 16G. And one of the reasons we want to do this test soon after they land is to see how capable the astronauts are going to be on that first EVA. Now, you might ask, didn't we do that already with Apollo? But Apollo did direct descent. They got to the moon within about 3 days, whereas the Artemis missions, they're spending more like 7 to 10 days in microgravity before they land on the moon. So they're going to have a little bit more sensory motor disruption.
Okay, so landing is soon. What is next for you and your team?
Yeah. Well, I've got some of my team is already out at San Diego right now, getting ready to support that landing and that test on that happens about 1 to 4 hours after they land. And the other portion of the team is now getting set up to do that EVA simulation over in Argos. So that's the active response gravity offload system over in Building 9. It's basically a fancy robotic crane that offloads a portion of the crew member's body weight so we can simulate lunar gravity.
So really the end of the mission is kind of when all of your work starts, for the most part, getting all of that post-flight data collection.
Yeah, so a lot of folks look at splashdown as being the end of the mission. That's, for us, kind of the start of when some of the most interesting data on the kind of human response to this mission begins.
So thank you so much for joining me, Jason. With one more question, what are you most excited about from learning for this mission?
Well, I'm excited about splashdown tomorrow. I mean, so is everybody. But in general, what I'm really excited is when we get them back over here at JSC, we put them through that EVA simulation, and because these astronauts didn't get a chance to land on the moon, but they get to pave the way for the Artemis 4 and 5 and so on astronauts, so they'll be prepared and ready to go. And I'm looking forward to that EVA simulation.
Well, that's great, and thank you so much. Again, this was Jason Norcross, lead for the obstacle courses that the Artemis 2 crew will be completing once they return back home to Earth. Thank you so much, Jason.
You're welcome. Thank you.
Integrity Houston for read with answer on fabric hinge and hatch. And you're coming in a little bit low. Hopefully you can hear me fine. So the fabric hinge on the docking hatch should be attached to both the hatch and the ship. And we're interested for the fabric hinge that was not connected to the hatch near Dog 3. Was it not connected to the carabiner? We'll take words on what wasn't connected.
Hey, Amy, for each fabric hinge, there is a nylon strap, and on each end of that nylon strap is a black carabiner. So on Dog 4, there was a black carabiner to the ship, and then the nylon strap, and a black carabiner to the docking hatch. At Dog 3, there was a black carabiner on the ship to the nylon strap, and then the black carabiner was back to the ship, so it's not connected to the hatch. It's very possible we did that on flight day 1 when we were doing cabin config. I just wanted to make sure both straps should have their black carabiners to the ship and to the hatch, which it sounds like is a true statement.
That is a true statement, Reed, and thanks for those details. Integrity Houston for toilet maintenance.
Go ahead.
Hey, first off, we wanted to check if the toilet canister R&R is complete, because if yes, we can restart wastewater venting.
It is complete.
Excellent. And then we have a delta for Victor's toilet maintenance activity. Victor can skip step 1. He does not need to replace oxone.
Okay, that's a bit of a surprise to us. We asked that question yesterday, so we did have to change it. So if we do not have to change it, we will go ahead and stow the oxone that we had time stowed. Copy all.
Yeah, we had some significant discussion about that down here. In the end, we want to preserve the system in its current state to better understand post-flight how the system was with regards to the slow wastewater vents.
Okay, sounds great. No oxone.
Thank you.
Houston Integrity, actigraph data retrieves complete on PCD-2.
Copy PCD-2.
This is Artemis Mission Control in Houston, Texas. We heard some communication there between the crew on board the Orion spacecraft and the team here in Mission Control Houston, specifically the CAPCOM, or capsule communicator, who for the current Orbit 2 shift is Amy Dill. The crew on board the Orion spacecraft is working through a handful of final tasks for their evening. One of those is related to some toilet maintenance as well as some actigraph data retrieval. The actigraph is a device that the crew is wearing throughout the mission as part of the Archer study. And this study will measure astronauts' well-being, activity, sleep patterns, and interactions during the Artemis campaign. And results from this will be used as part of a behavioral performance study, and results from each mission will be used to understand the combined effects of space hazards on well-being and performance, and also to help develop protocols, interventions, and technologies to enable humans to survive and thrive for future Moon and Mars missions. In addition to that actigraph data retrieval and the toilet maintenance that NASA astronaut Victor Glover is working through, NASA astronaut Christina Cook and Canadian Space Agency astronaut Jeremy Hansen are both working through an off-nominal waste management system developmental flight test objective, during which the crew are performing a fit check of that off-nominal waste management system prior to donning their orange Orion crew survival system suits. In addition, NASA astronaut Reed Wiseman is also working on some side and docking hatch entry configurations, during which he is inspecting and configuring both of those hatches in advance of re-entry, which will take place tomorrow, April 10th.
Houston Integrity, any issue with me starting the RHC THC checkouts a little early?
Checking. No concerns, Reed. You can start RHC THC early.
Going to work, thanks.
This is Artemis Mission Control in Houston, Texas. You heard another call down there from NASA astronaut Reed Wiseman, who is the commander of the Artemis 2 mission, to the team here in Mission Control Houston regarding another upcoming activity on his timeline. This specific activity related to a checkout of the rotational hand controller. During this checkout, he will ensure that there are sufficient deflection checkouts to ensure that a crew can track each target using that rotational hand controller. And this checkout is performed as part of the pre-entry systems checkouts. Currently on your screen, in the upper left corner, you can see a live view of the Orion spacecraft. That view coming to you from one of the solar array wing cameras, and you can actually see a pretty good view there of one of the solar array wings in the upper portion of that image. There are 4 total solar arrays attached to the surface module of the Orion spacecraft, and each of those solar arrays does have a camera, which helps to provide some of these live views throughout the mission. In the bottom right-hand corner of your screen, you can see a view inside Mission Control here in Houston, Texas, specifically the Artemis Flight Control Room. Currently on console inside the Artemis Flight Control Room is the Orbit 2 team of flight controllers. They are being led by Flight Director Fiona Yankoviak, and the Capcom or capsule communicator right now is Amy Dill. Also on that screen next to Capcom Amy Dill in the bottom left-hand corner, you can see NASA astronaut Nicole Ayers, who is joining Amy on the Capcom console. And then next to Amy in the upper right-hand portion of that image, you can see Flight Director Fiona Yankoviak, and a fellow flight director is also next to her, and that is Flight Director Chloe Maring.
Houston integrity. The off-nominal waste management system DFTO is complete. Off-nominal waste management systems are stowed. We will now use nominal waste management for the remainder of flight.
Houston copies.
And Houston integrity for step 5 of off-nominal DFTO.
With you.
Yes, Amy, I would like to do the option of privatized OE2 for providing feedback if that is available.